All right. What is this? Chapter 3, page 50. Stalking the Wild Pendulum. Let us go back to the old grandfather clock with its leisurely swinging pendulum and see what is unusual about its movement. Apparently, there is nothing unusual. Its motion can be described as being made up of motion and rest. We recall vaguely having heard something like this before. Let us analyze the motion of the pendulum. As it approaches its point of rest, it slows down more and more. Eventually, it stops and starts moving in the opposite direction. The law of classical mechanics tells us that at the point of rest, the acceleration of the body is maximum. Its potential energy is maximum. Its velocity is zero, and the time required to change the velocity of the pendulum is zero. We analyze the events taking place at the 0 point from the point of view of quantum mechanics. We get a different picture. If we analyze the events taking place at the 0 point from the point of view of quantum mechanics, we get a different picture. Let us view the pendulum bob as a mathematical point, that is, a point that is too small to be measured, a dimensionless point, and follow its progress as it slows down. Clearly, the point will cover a smaller and smaller distance per unit time as it approaches its turning point. But quantum mechanics tells us that when distances go beyond Planck's distance, which is 10 to the 33rd centimeter, we enter, in effect, a new world. The causal relationship between events breaks down, movements become jerky rather than smooth, time and space may become grainy or chunky. Perhaps a piece of space can be traversed by a particle of matter in any direction without necessarily being synchronized with a piece of time. In short, a pair of events would occur in either time or space, the pair not being connected causally, but by random fluctuation. Suppose indeed that a material point can traverse space without necessarily requiring any chunk of time for the process. Should this happen, then a chunk of space has been spanned without any time elapsing. If we divide that tiny piece of distance to zero time, we find that the event occurred at infinite velocity. In other words, when we move through space without using up time, no matter over how short a distance, that event occurs at infinite velocity. There is a principle in physics that states that any event that is not prohibited by the laws of physics should happen. What then happens to the pendulum? All the points on it behave the same way, therefore all of it must for a tiny fraction of a second move at infinite velocity. Can a physical object move faster than the velocity of light? Let us approach this from a different angle. We have heard about Heisenberg's principle of uncertainty. This principle states that in trying to measure two parameters of a particle, for instance, its momentum and its position, we find that the more accurately we can measure its momentum, the less we can know about its position and vice versa. Momentum simply means mass x velocity. If we want to measure either the momentum or the position of a particle, we can measure precisely only one of these quantities. If we know the exact momentum of a particle, then its position is completely indefinite and or unknowable, and vice versa. This is an example of those strange ways in which particles of atomic size or smaller behave. We know at a rest when the pendulum is changing direction, its velocity is zero, but the momentum at low speeds at least is equal to velocity multiplied by mass. However, if we multiply any quantity by a zero, we get zero. Thus, we have now established that the momentum of the pendulum at the point is zero. At that point is zero. That is, we know its value very precisely. It's zero. But we have said before that if we know precisely the momentum of a particle, then its position becomes diffuse and completely indefinite. That is, the pendulum can be just about any place, even at the end of the universe. Yes, but it has very little time to get there because this whole event occurs in zero time. But there we go again. The pendulum has to disappear in all directions at infinite velocity. It will have to expand very rapidly into space, like a balloon, and then collapse just as rapidly. Having done this, it comes back, picks up speed, and goes about its usual good-natured business as if nothing had happened. None of us would suspect the leisurely pendulum of doing such a wild thing when no one is looking. But then again, one cannot rely on appearances. To bring in a more easily digestible model for this behavior, let us take a camera. Suppose that we want to photograph a bird in flight by prevailing light. We know that if we want to get a sharp picture of the bird, we have to use a very short exposure time, say 0.001 second. We look at our exposure meter and we find that at 0.001 second, we won't have enough light to register the image on the film. And to get sufficient light, we would need at least a 0.1 second exposure. But we know that in 0.1 second, the bird will be out of sight, and all we shall see on the picture would be a streak representing the bird. So we are in trouble either way. In other words, you can't have your cake and eat it too. We have so far been using the pendulum as an example. But the pendulum represents any system that oscillates or moves back and forth, whether such an oscillator pulsates concentrically, goes around its orbits, or turns about itself. From the standpoint of one observer, there are always 2 points at which either of these systems appear to be at rest. But to be completely at rest, that is, being at the point at which movement in one direction is changing sign or reversing direction. That point of rest implies somehow a disappearance of matter and a movement at infinite or almost infinite velocities. Infinite speed and total rest seem somehow complementary. Until now, we use the pendulum as a model because it is easy to visualize. However, the atoms of matter at room temperature vibrate at a rate of about 10 to the 15th hertz. Therefore, it is very likely that our matter is blinking off and on at any rate. I'll keep going. Objective and subjective realities. In Chapter 2, we looked through a super microscope and discovered that our objective reality is made up of void vacuum, which is filled by pulsating, oscillating electromagnetic fields that in turn move between 2 points of rest. Each of the points of rest is reached through a period of motion. In the beginning of this chapter, we tried to analyze the nature of our subjective reality. We know that it consists of the sum total of impressions conveyed to us by our senses. Then we found that our nervous systems translate the objective reality for us in a Morse code of action or motion and rest, which are oscillating electrical states of the nervous system. We can thus extract a common denominator of our objective and subjective realities. We shall find that both realities become real only due to the change of motion occurring between the 2 states of rest. In other words, if there is no change, we have a state of perpetual rest, and a state of perpetual rest means no perceivable reality. It may be useful for us to ponder the possibility that tangible reality exists for us only as long as there is movement, and when the movement stops, matter and solid reality become diffuse and disappear. At this point, I can no longer resist the temptation to quote from a book by Alexandria David Neal and Luma Yongden entitled The Secret Oral Teachings in the Tibetan Buddhist Sects. The tangible world is movement, says the masters, not a collection of moving objects, but movement itself. There are no objects in movements. It is the movement which constitutes the objects which appear to us. They are nothing but movement. This movement is a continued and infinitely rapid succession of flashes of energy, in Tibetan, tsal or shog. All objects perceptible to our senses, all phenomena of whatever kind and whatever aspect they may assume, are constituted by a rapid succession of instantaneous events. There are 2 theories, and both consider the world as movement. One states that the course of this movement, which creates phenomena, is continuous, as the flow of a quiet river seems to us. The other declares that the movement is intermittent and advances by separate flashes of energy which follow each other at such small intervals that these intervals are almost non-existent. It seems that someone was here before, but where does matter go when it periodically disappears? And what happens to us as we blink on and off? We will learn about this in the following chapters. Summary. Our senses translate to us the physical reality in a Morse code of action and rest. This is our subjective reality. We can compare this action and rest language to the motion of a pendulum or an oscillator. We have shown that when the pendulum reaches its point of rest, it has to become non-material for a very short period of time and expand into space at an almost infinite velocity. A quote from the Tibetan Buddhist book suggests the same. Tangible world is movement. Without change or movement, there is no object or subjective reality. You got that?